Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. In this small session, I am going to discuss one important question from GATE 2023 Electrical Engineering paper. The question belongs to power system and it was a Y bus question. The Y bus matrix is given. It was a GATE 2023 examination which was very recently conducted, and the subject is power system. Because this was a good question, it was a tricky question, so I thought of giving a complete explanation for this question, because it will not only tell you whether you have opted the correct answer for this question or not. At the same time, it will also give you a better understanding of what is the difference between a shunt element and the line charging capacitance. Let us read the question carefully. The question is saying, the bus admittance matrix of a 3-bus power system is given. So there are 3 buses. So 1, 2, 3 and 1, 2, 3. The elements of the Y bus matrix are given. Now he is saying, consider that there is no shunt inductor connected to any of the buses. Already it is clearly mentioned in the question that there is no shunt inductor connected to any of the buses. Now he is asking, which of the following cannot be true? It means you have to identify the incorrect statements. You have to select the incorrect statements. It was a MSQ question. And it carried 2 marks. And it was a very interesting question. So first I am going to give you the solution, and then we will examine each and every statement out of the conclusion we are going to get. Now there is a confusion that how this system is going to be. So I am going to take the most general case, and then I will try to find some conditions. So suppose there is a 3-bus system. Okay. These are the 3 lines between any of the 2 buses. Suppose this is bus number 1, this is bus number 2, and suppose this is bus number 3. So this is going to be Y12. When I am writing Y12, it means I am talking in terms of the admittance. So there should be no confusion. Even if it is going to be inductive, still you can write it in the admittance form. No confusion. The admittance between Y2 to 3 is going to be Y23, and between 3 to 1 is going to be Y31. So you can write Y12 also, Y21 also, same thing. Y23 also, Y32 also, same thing. Y31 also, Y13 also. Why I am saying it is a most general case? Because I am assuming that all the 3 buses are having the shunt element. All the 3 buses are having the shunt element. These are the shunt elements I am connecting to all the 3 buses. This is going to be Y10, this is going to be Y30, and this is going to be Y20. Now again, to make it a most general case, I am assuming all the 3 lines in this system, they are having the line charging capacitance. Now you first understand what is the line charging capacitance. When you model your transmission line, why you model your transmission line? You model your transmission line because you want to represent each and every physical phenomena which is happening in your line in terms of the circuit element, electrical circuit element. Are you getting that? Now, because of the capacitance between the line and the earth, you want to represent this phenomena. That phenomena is represented by using shunt capacitances, and these are called as line charging capacitances. Generally, we are using the nominal pi model. Some students may ask me, sir, why you are not using the nominal T model? If you can use nominal T also, but that will make your system more complex because one extra node is going to be added. See, if you are using in nominal pi model, then what will happen? This extra node is going to be added into the system. So that will make your system more complex. To avoid this situation, we are going for nominal pi model for each of these lines. And I am introducing line charging capacitances in all the lines. So line 1 to 2, because it is capacitance, so directly we can put the capacitance. Make it the most general case, and I am writing it as Y charging 1 to 2 divided by 2. The whole admittance is going to be divided into two equal parts at the two ends. This is going to be Y charging 1 to 2 divided by 2. Similarly, for line 2 to 3, you will have two line charging capacitances, and this is going to be Y charging 2 to 3 divided by 2. Another line charging capacitance, this is Y charging 2 to 3 divided by 2. Similarly, for line 3 to 1 also, you will have Y charging 3 to 1 divided by 2. Similarly, here also you will have Y charging 3 to 1 divided by 2. And I am again repeating, there is no difference whether you write 3 to 1 or 1 to 3. These are the same things. Now, for this most general case, can you help me write the Y bus? Yes or no? So I will be writing first the diagonal elements. What is going to be Y11? What is going to be Y11? All the branch admittances directly connected to bus number 1. So just add up Y10 plus Y12 plus Y31 plus Y charging 1 2 divided by 2 plus Y charging 3 1 divided by 2. Y charging 3 1 divided by 2. So these are all the admittances, branch admittances, and whatever admittances directly connected to bus number 1, I have just added up. Can you tell me what is going to be Y22? Yes, Y20 shunt element. Then Y12, Y23, Y12, Y23, and the line charging capacitances. For bus number 2, it is going to be Y charging 1 2 by 2, Y charging 1 2 by 2 plus Y charging 2 3 by 2, Y charging 2 3 by 2. Similarly, you can write for the third bus, the diagonal element. For third bus, it is going to be Y30 plus Y23 and Y31, Y23 plus Y31, and the line charging capacitances, Y charging 2 3 by 2, Y charging 2 3 by 2 plus Y charging 3 1 by 2, Y charging 3 1 by 2. So I have got the diagonal elements. Now I will be writing the off diagonal elements. Okay. So off diagonal element, suppose Y1 to 2, it is going to be minus Y12. Yes or no? But this value is already mentioned in the question. What is this value? What is Y12? Y12 is J10. So this is going to be J10. So can you tell me what is actual Y12? It is minus J10. What is Y13? It is minus of Y13 or Y31, whatever you want, you can write. And this value is also mentioned in the matrix in the question. It is J5. This is J5. So what is going to be Y13 or Y31? It is minus J5. What is going to be Y23? It is going to be minus of Y23, and that is already mentioned. Y23 is going to be J4. So this is J4, or you can write Y23 is minus J4. What is going to be Y12, 13, 23 already we have taken. So what is the remaining thing? 1 2 we have taken, 1 3 we have taken, Y21 is same, Y23 is same, Y31, Y32. So everything we have got, no problem. Okay, because this is going to be same as Y21, this is going to be same as Y31, and this is going to be same as Y32. So you got all of diagonal and diagonal elements, and you have also found the branch admittances for 1 to 2, 2 to 3 and 3 to 1. Yes or no? Okay. Now these values I am going to put in these equations, and let us see what condition we are getting for these line charging capacitances. So for the first equation, if I am going to put, what is this y11? As per the matrix, y11 is minus j15. This is minus j15. What is y22? What is y22? y22 is minus j13.5. It is minus j13.5. What is y33? y33 is minus j8. It is minus j8. Now you know what is the value of y12 and y31. Just put these values. Only y10, y charging 12 by 2, y charging 31 by 2 is going to be the unknown. So I am writing it again. As per first diagonal element, it is going to be y10 plus y charging 12 by 2 plus y charging 31 by 2, and this is given as minus j15. And what is y12 and y31? y12 is minus j10 and y31 or 13 is minus j5. So this is going to be plus j15, because minus j15 from here, it will go to right hand side with plus j15 and it is going to be cancelled. So you will be getting 0. So the condition you are getting here is y10, or let me just rearrange it so that you can better understand. Y charging 12 by 2 plus y charging 31 by 2 is equal to, because that is 0, so take y10 to the right hand side, it becomes y10. I want you to focus on this equation, He is saying that line charging capacitances, these two capacitances, must be compensated by this y10. Yes or no? Yes? And this can only be possible if this y10 is going to be an inductor or reactor. But in the question it is clearly mentioned, no shunt inductor is connected to any of the buses. It means if this y10 cannot be inductor, then this is only possible when this is also 0, this is also 0 and this is also 0. Because there is no other possibility. Because these two charging capacitances, both are capacitances. Now together they can be compensated only if there is some shunt inductor is connected to bus number 1. But it is in question it is mentioned that there is no shunt inductor connected to any bus. So the conclusion is y charging 12 has to be 0 divided by 2, or simply you can write, or y charging 31 by 2 also has to be 0, and y10 has to be 0. So you can write some conclusions. No shunt element or shunt capacitor also you can write, or simply element, no shunt element connected to bus number 1. Okay, this is conclusion. Y charging 1 to 0 means what? Line 1 to 2 has no line charging capacitance. And similarly you can write for line 3 to 1 also. So let me just edit here itself. Line 1 to 2 and line 3 to 1. 1 to 2 and 3 to 1 have no line charging capacitances. This is the conclusion we have got out of this equation. Now let me write for the second equation. Second equation, this is unknown, y20 is unknown, y charging this is unknown, and y12, y23 you know. So you can write y20 plus y charging 12 by 2, Y charging 1 2 by 2 plus Y charging 2 3 by 2, Y charging 2 3 by 2 is equal to how much? It is mentioned minus J 13.5, minus J 13.5. Now what is going to be Y12 and Y23 together? Y12 and Y23 together. So Y12 is minus J10, and what is Y23? It is minus J4. So minus J10 minus J4 becomes minus J14, and this minus J14, when it goes to the right hand side, it becomes plus J14. So if you simplify, you will get J 0.5. Now from the previous conclusion, we know that Y charging 1 to 2, because line 1 to 2 is not having any line charging capacitance, so this has to be 0. So this is going to be 0. So you can write Y2 naught plus Y charging 2 3 by 2 is J 0.5. Now understand what is the meaning of this equation. There can be infinite ways in which you can connect a shunt element in the second bus. Are you getting this? And line charging is going to be present between 2 to 3. Because together this capacitance, whatever capacitance is coming, it has to be compensated by this. Are you getting this or not? I have written admittance. In terms of admittance, I am writing, that is why I am saying capacitance. So even if no shunt reactor is connected, there is sufficient, you can say, J 0.5 is going to compensate both of these capacitances together. So the conclusion is bus 2 has shunt capacitor and line 2 to 3 has line charging capacitance. This is what the conclusion you can draw. There can be infinite number of ways in which you can put various values for Y20 and Y charging 2 3, and you will get various combinations, but we have to draw some general conclusion. Similarly, you can write for the third equation, Y33. So it is going to be Y3 naught plus Y charging 2 3 by 2, Y charging 2 3 by 2 plus Y charging 3 1 by 2 is equal to, this is minus J8. Now what is going to be Y23 and Y31? Y23 and Y31. Y23 is minus J4 and Y31 or 13 is minus J4. So together they become minus J9. Minus J9 going to the right hand side will become plus J9, that is nothing but J1. Again, Y31 charging is going to be 0. Already we have concluded. So Y3 naught plus Y charging 2 3 by 2 comes out to be J1. So again there can be infinite ways, infinite values which you can put for Y30 and Y charging 2 3, and you can get these two capacitances being compensated by this, because the equation has to satisfy. So the conclusion you can draw is that bus 3 has shunt element and line 2 3 has line charging capacitance. I hope you are getting now what this question was trying to ask you. I am going to make a final circuit for this so that you can understand it better. So suppose this is the case. Okay, this is bus number 1, bus number 2, this is bus number 3. 1 to 2 is not having any line charging capacitance, 1 to 3 also are not having any line charging capacitance, but 2 to 3 can have line charging capacitance. So something like this. Bus number 2 has some shunt capacitance, because shunt reactor is not possible as per the question, so the only possibility is shunt capacitor. And bus 3 also can have some shunt capacitor as Y3 naught. This is Y2 naught. This is Y charging 2 3 by 2. This is Y charging 2 3 by 2. This is Y12. What is Y12? Y12 is minus J10. So it becomes minus J10. What is Y23? Y23 is minus J4. So it is minus J4. What is Y31? Y31 is minus J5. It is minus J5. So this is the final circuit you are getting, okay, as per the conditions we have got, and now we are going to analyze the statements given in the options. Let us go to the first option. Line charging capacitor of finite value present in line 2 3 only. Okay, so this is correct. This statement is correct. Only line 2 3 is going to have the line charging capacitance, not 1 and 2, not 3 and 1 or 1 and 3. So this is correct. But he is asking which are not true. You have to identify the incorrect statement. So even if this is a correct statement, but this cannot be our answer because we have to choose the incorrect statement. Option B, line charging capacitor of finite value present in line 2 3 only. Now up to this it is correct, and shunt capacitor of finite value present in bus 1 only. Because it is written only, that is why it is wrong. There is a possibility. So this is incorrect statement, and because it is incorrect, so this is going to be your correct option. And because it is MSQ, more options are going to be correct. Option C, line charging capacitor present in all 3 lines. This is wrong because line charging is present only in line 2 and 3. We have already seen it. We have concluded. So this is also going to be the correct one. D option, line charging capacitor of finite value present in line 2 3 only. Up to this it is correct. And shunt capacitor of finite value is present in bus 3 only. This is wrong. This is wrong. It may be present on 1 also, 1 and 3 both also. So this is incorrect. So because this is incorrect, so D is also going to be the correct answer. So the final answer which you have to put in your answer sheet is B, C, D. The answer should be, for this question, if you mark B, C, D as your final answer, then only you will be getting the marks for this question. So I hope you got the clarity how you are going to form the Y bus when line charging capacitances are present, and this type of question now I think you can effectively handle. So thank you so much, and before you leave this session, subscribe to BYJU'S Exam Prep for all these important updates. Thank you so much. Thank you everybody.